started, sir.
Okay. Welcome to Ask Engineering Academy, Ecet examination entrance coaching. The students who are prepared Ecet examination, welcome to all. If any student are prepared Ecet examination, you prefer online classes or offline classes, you listen these live classes, and any doubts you can contact on comments or whatever it may be directly also. You cleared your doubts, and also all the best the people who are prepared Ecet examination 2025. This Ask Engineering Academy is located near to ARK Healthcare Hospital, Dilsukhnagar, Madhurapuri colony. Okay, the students who are prepared Ecet examination, you can listen these live classes. It is especially useful for you and also benefit for you, and listen, and also in the comment section you can comment any doubt. Okay, students. Thank you. Now I am going to start water technology. About this unit in the examination, most important questions to come in the examination, either 2 or 3 questions in that particular unit only. Okay, these complete entire the syllabus, and what are the questions most probably they are giving in the examination, that questions I am going to discuss now. Now you can see this is the syllabus of water technology. Introduction, soft and hard water, causes of hardness, types of hardness, disadvantages of hard water using industries, degree of hardness, softening methods, permitted process, and ion exchange process, drinking water, municipal treatment of water, drinking purpose, osmosis and reverse osmosis. Reverse osmosis advantages, and reverse osmosis, these all desalination of electrodialysis, defluoridation and Nalgonda technique, etc. This is the syllabus of water technology. In this I am going to discuss one by one. You can see here. First I would like to introduce about this unit, introduction. Everybody know water is a natural source. It is obtained from different sources like surface water and groundwater. What are surface water examples? Rain water, river water, lake water, sea water, etc. These are belongs to what more? Surface water. What are groundwater or underground water? What more? Pond and well water is belongs to what more? This groundwater or underground water. These water everybody know absolutely it is a natural source, which is a natural source, directly not possible to human being consumption for drinking. When it is possible to useful for drinking after the purification, it is possible to drinking purpose. Okay, water present, why this water is not useful for directly for drinking purpose means, here either naturally, this is the naturally occurring elements or minerals or different contaminants, salts by human activity, etc. are going to dissolve in that water. That water contains lot of dissolving salts, that's why that water is not possible to use for drinking purpose. Okay, that's why here water is nowadays most of the people are going to use it for drinking purpose after the purification. Okay, here what are the source of water? Here Just a minute. Introduction. What are source of water? Source of water, we have two types. One is ground water. Next, second one, surface water. What are groundwater? Here, pond and well water. What are examples of what more? Groundwater. Here, surface water we have. One is rain water, 2 river water, lake water. Next, fourth one, sea water. These are different source of water. These water containing many of dissolving salts. That's why this water is not going to suitable for drinking purpose. Okay. Then dissolving of these salts or contaminants, what happen? Now I am going to discuss. Next, what more? Next, soft and hard water. Due to the dissolving salts of different chemical substances and impurities and salts etc. is dissolving in the water, this water occurs hardness. Now I am going to introduce about soft and hard water. Soft and hard water. What is mean by soft water? Soft water means the water which gives much lather with soap is called soft water. The water which gives much lather with soap easily and immediately is known as what more? Soft water. Soft water always will give much lather with soap. Here soft water. Here what I am saying to you, the water which gives much lather with soap easily and immediately. What is soap chemical formula? C17H35COONA. Soap. Sodium salt of stearic acid. Soap is whenever combined with H2O, what is going to form? C17H35COOH. Stearic acid is going to form. What is remaining? Byproduct is going to release as what more? NaOH. Here no salts, directly water is going to combine with the soap substance continuously to produce what more? Stearic acid and giving much lather. Next, what about hard water? Hard water, exactly opposite to for this. Here the water which does not gives much lather with soap easily and immediately is called hard water. Hard water means what more? Once again you listen carefully what I am saying to you. The water which does not gives much lather with soap easily and immediately is called hard water. Here how they react? Here C17H35COONA, 2 moles I am taking, which is going to react with first dissolved calcium and magnesium salts or any other substances. Here for example in that water what are present? For example calcium chloride may be present, this hard water. HW means hard water contains what more? CaCl2. This CaCl2 is going to react with first C17H35COO taken twice calcium plus remaining 2 sodiums and 2 chlorines are combined to form 2 NaCl, here to form as a byproduct 2 NaCl. Once again I am concluding these 2 points with comparison. Soft water means what? The water which gives much lather with soap is called soft water. The water which does not give much lather with soap is called hard water. Why the hard water is not giving lather means due to dissolving impurities of calcium and magnesium. This is about what more? Soft and hard water. Next, causes of hardness. What are the salts causing hardness? Here, causing hardness, different calcium and magnesium salts are causing hardness. What are they? I am writing here: bicarbonates of calcium and magnesium, chlorides of calcium and magnesium, sulfates of calcium and magnesium, and nitrates of calcium and magnesium, etc., causing hardness. Due to these calcium and magnesium salts present in the water, either whatever the source which is available, either groundwater or surface water, whatever it may be, these salts are dissolving that water. Absolutely, they do not produce much lather. Here I am writing calcium and magnesium salts. Mainly, what are the salts producing causes hardness? Calcium and magnesium salts. First one, bicarbonates. Here calcium bicarbonate, CaHCO3 taken twice, MgHCO3 taken twice, its formulas. Next, second one, chlorides of calcium and magnesium, CaCl2, MgCl2. Okay. Next, third one, sulfate, CaSO4, MgSO4. Next, nitrates. What are nitrates? Here I am writing CaNO3 taken twice, MgNO3 taken twice. These are the salts producing hardness. If in case these are the salts absent in the water, that water automatically to gives much lather, then that water is treated as what? More soft water. Okay, it is clear. Whenever these salts are dissolving in the water, only the water is treated as what? More hard water. Whenever these salts are absent, that water is simply treated as what? More soft water. Okay, this is about causes of hardness. These are the salts causes hardness. Here, this only bicarbonates are producing what? More temporary hardness. And remaining salts, chlorides, sulfates, nitrates of calcium and magnesium produces permanent hardness of water. Okay, clear mo? Only bicarbonates of calcium and magnesium, they produce temporary hardness, and chlorides, sulfates, nitrates of calcium and magnesium produces permanent hardness. If in case in the examination, which of the following salt produces temporary hardness, which of the following salt produces permanent hardness, like this chemical compounds are given in the examination, Ecet examination. Okay, you can observe carefully. Next, I am going to next topic, types of hardness. Here again given types of hardness. We have total two types of hardness, that is temporary hardness of water and permanent hardness of water. Here, first of all, I would like to introduce what is meant by hardness of water. The property of hard water which prevents the formation of lather. Is called what? More hardness of water. What is meant by hardness of water? The property of hard water which prevents the formation of lather is known as hardness of water. Why here preventing the lathering means due to presence of dissolving calcium and magnesium salt, which may be chlorides, which may be bicarbonates, which may be sulfates, which may be nitrates, whatever it may be present in the water as a dissolved state, that are going to what more responsible, they do not produce lather, which are preventing the formation of lather. Here two types of hardness we have. One is temporary hardness of water. Listen this. Temporary hardness of water is caused due to the dissolving salts of dissolving salts of calcium and magnesium bicarbonates. Calcium and magnesium bicarbonates. Here what are the salts responsible temporary hardness means only bicarbonates of calcium and magnesium are responsible temporary hardness. This temporary hardness can be removed by boiling. Temporary hardness can be removed by simply on boiling method. Here I am writing that reaction. Examples: calcium bicarbonate whenever present as a soluble state in the water, on boiling, simply delta symbol it is used. This one is going to convert CaCO3 plus CO2 plus H2O etc. Here downward arrow mark. This is insoluble substance to be formed. Okay, this insoluble substance after boiling to obtain, whenever insoluble substance is formed, that is going to separating with the help of filtration. Okay, next also one more example we have magnesium bicarbonate, which is also soluble state, after boiling this is going to convert into magnesium hydroxide and releases 2 moles of carbon dioxide, magnesium hydroxide. This is also insoluble substance. This temporary hardness, how to remove? Just in the examination is possible. How to remove temporary hardness? Different options they are framing in the question paper. Here what is your answer? Temporary hardness can be removed by boiling method. Boiling method, that is one method. And second one, permanent hardness of water. Permanent hardness of water. Here permanent hardness is caused due to the dissolving salts of calcium and magnesium, chlorides, sulfates, nitrates, etc. Permanent hardness is caused by the dissolving salts of chlorides, sulfates, nitrates of calcium and magnesium. This hardness cannot be removed by simple boiling method, and it can be removed by specific methods like lime soda method, permitute process and ion exchange process etc. This hardness cannot be removed by boiling. In your examination simply they are given which of the following hardness cannot be removed by boiling means only permanent hardness cannot be removed by simple boiling method. Here what are the salts responsible permanent hardness means except bicarbonates. Remaining salts are producing what more? Permanent hardness. Permanent hardness producing salts what more? Calcium chloride, magnesium chloride. These are producing what more? Permanent hardness. Calcium sulfate, magnesium sulfate. Next calcium nitrate and magnesium nitrate etc. produces what more? Permanent hardness. Permanent hardness cannot be removed by boiling. It can be removed by some specific methods like ion exchange method, permitted process, lime soda method etc. process. This is about types of hardness of water. Okay. Next I am going to discuss about disadvantages of hard water using in industries. Disadvantages of hard water using in industries. Here what are the disadvantages using in industries? For example, whenever hard water is going to used for sugar industry. Here what happened during the preparation of sugar, water is needed. Generally whatever the industry requires, either domestic purpose or industrial purpose, water is mainly needs compound. Here what happened, whenever sugar industry this hard water is going to use, the crystallization of sugar is difficult. Here what happened more? Crystallization of sugar is difficult. In what more? In sugar industry. What happened? Whenever hard water is used, the sugar crystallization is difficult. Here what happened? Whenever hard water is used, crystallization of sugar crystallization of sugar difficult. Crystallization of sugar difficult. That is one. And textile industry, what happened? Textile industry, few points I discussed here. Whenever hot water is used, in textile industry, what are the disadvantages? Most probably textile industries, this hot water is going to use that cloths are not going to clean 100%. Here what happened? Whatever the textile industry, whenever hot water is used, it consume more soap. Why? Means that one not giving much lather due to presence of many of salts. That salts also is going to deposited on cloth surfaces, and also the color fades. The cloth color also is fade due to using of hot water. That is also one. And also paper industry. What happened? Whenever the preparation of paper also required water, in this case also we are using hot water. What happened? The paper quality is not obtained good. Whenever soft water is using, the paper is obtained like pure white color. Whenever hot water is used, the paper is obtained lightish brown color paper to obtain. That is the difference between whenever using soft water and whenever using hot water differences. Here what happened? Paper quality is going to reduce whenever using of hot water. And also, for example, the salty water used in what more? For example, drinking purpose. Nowadays, no people are going to use drinking purpose this direct water. If someone using this water directly for drinking purpose, what happen? Many of salts are dissolving. Hard water means what more? Many of salts already present in the dissolved state in that water. That many salts are consuming human beings also getting problems to get whatever the disease is. That much dissolving salts are not going to filter human being kidneys, which means it is possible to store formation of kidney stones. Here why they form kidney stones mean what more? Many of salts they consume. Hard water they consume regularly. What happens? That many salts are not going to filter human being kidneys. That is also one of the problem to consuming directly hard water in drinking purpose. These are few disadvantages I given here. Few disadvantages I discussed here. Next I am going to continue the next topic. You can see degree of hardness. Degree of hardness or what more? Degree of hardness. Here I am writing degree of hardness means or hardness of water should be say the property of hard water which prevents the formation of lather. Is hardness of water or degree of hardness. This degree of hardness can be expressed in terms of calcium carbonate equivalence. Degree of hardness means what more? The property of hard water which prevents the formation of lather due to presence of dissolving salts here prevent the formation of lather. That hardness can be expressed in terms of calcium carbonate equivalence. Here hardness of water or degree of hardness of water, is expressed in terms of CaCO3 equivalence. Okay, here hardness of water or degree of hardness is expressed in terms of CaCO3 equivalence. Here hardness of water, degree of hardness of water in terms of CaCO3 equivalence is written like EQ. Here weight of hardness causing salt, hardness causing salt divided by GMW of hardness causing salt, H dot C dot S, here I wrote full H dot C dot S into 100. What is this 100? Gram molecular weight of calcium carbonate, this gram molecular weight of calcium carbonate, which is expressed in terms of calcium carbonate equivalent. That's why which is going to multiply with that 100. 100 means what more? Gram molecular weight of calcium carbonate. And also one more formula also we have, weight of hardness causing salt divided by GEW, gram equivalent weight of hardness causing salt into 50 more, into 50. What is this 50? Gram equivalent weight of calcium carbonate, gram equivalent weight of calcium carbonate. This formula useful for calculating hardness. Whenever given problems for calculating of hardness, this formula is going to help to calculate hardness of water problems. Next I am going to next topic, softening methods. Water softening methods. Here water softening methods we have, one is what more? Simple boiling method that you know everyone. Here what is that? Boiling. Softening method we have boiling. Softening methods, here total we have what more? Water softening methods. Whatever discussed here, hard water containing many of calcium and magnesium dissolving salts. Due to presence of these dissolving salts, what happen? This is what more? Not suitable for human being consumption, especially for drinking purpose. Why means many of salts are dissolved in it. Absolutely, any people are commonly said many of salts are present means that is not suitable for drinking purpose. Here that water is needed purification, means here what are the methods given? Softening methods. One is boiling and one is Clark's method and permutate method, ion exchange method. We have different methods. Here whatever we have in syllabus, that one I am going to discuss, permutate and ion exchange. Then after drinking water we have here softening method. Here I am writing what more? Boiling. Boiling method also we have. Boiling means what more? Whenever hard water dissolving only bicarbonates, the hard water only dissolving bicarbonates of calcium and magnesium, whenever bicarbonates are dissolving in the water, that water is simply treated on boiling method, that bicarbonates of calcium and magnesium are going to convert into insoluble substances and remove temporary hardness. Here how is removed? Whenever calcium bicarbonate was dissolved in hot water, this one is going to boil. Boiling. Simply this one is going to convert into calcium carbonate, precipitate, inward arrow mark, CO2 gas plus H2O etc. form. This is present in soluble state. This is present in what more? Insoluble state after boiling. This is what more? Boiling method 1, the simplest method. In boiling method only bicarbonates are removed, not removed by chlorides, sulfates, nitrates of calcium and magnesium. Only this boiling method can remove only calcium and magnesium bicarbonates whenever dissolving in the water. Next we have Clark's method. Clark's method. Here Clark's method only it removes permanent hardness. It removes only temporary hardness. Boiling method removes only temporary hardness. Temporary hardness of water it removes. Here Clark's method removes only permanent hardness of water. Permanent hardness of water. What are the salts responsible permanent hardness of water? Chlorides of calcium and magnesium, nitrates of calcium and magnesium, sulfates of calcium and magnesium, etc. responsible permanent hardness. Here Clark's method very simple. Whatever the water dissolving permanent hardness causing salts are present in that water we need to add slake lime, calcium hydroxide. Slake lime, what is the chemical formula? Calcium hydroxide. Add to this and then converted soluble products into insoluble substances and removed permanent hardness. For example, any dissolving salt you can take. For example, magnesium chloride may be dissolved in the water. This can be added calcium hydroxide, slake lime. What is this? Slake lime. They converts into 2 moles. Here magnesium hydroxide. They converts into what more? This magnesium chloride is going to converts into magnesium hydroxide. Remaining they produce calcium chloride. Remaining they produce what more? Calcium chloride. This calcium chloride again reacts with, that is also producing what more? Continuously whenever this form what more? Insoluble substances and removes. That calcium chloride again reacts with calcium chloride. One more, that calcium chloride also is responsible permanent hardness of water. CaCl2 is combined with again CaOH taken twice. They form CaCO3. They form. Here they require 2 moles of calcium hydroxide. Here required whenever calcium chloride is present, CaCO3 required, and what is remaining? Whenever required calcium hydroxide, CaCO3 completed, and remaining compound they form. Here not required any removal of calcium chloride. Here what more? Whenever this one only required, just a minute. After removing this magnesium chloride whenever present, which is going to adding with slake lime and removes what more? Permanent hardness of water. In your examination point of view, what are given question? Which of the following method removes permanent hardness? They are giving boiling method, Clark's method, any other method they are given in the exam. Whenever adding slake lime and removes permanent hardness of water, that you remember carefully. Next we have permitted process and ion exchange process. I am going to explain. Here I am going to divide to 1 minute. 2 columns. One column for what more? Permitted process. One per permitted process or zeolite process, zeolite method. Here listen, permitted process, one of the water softening method. Here zeolite is used as what more? Water softening substance. What is going to use? Zeolite is going to use. That zeolite contains large number of microporous structure. What is the zeolite formula? Here I am writing zeolite Na2O Al2O3 XSiO2 dot YH2O. This is the chemical formula of zeolite. Exactly what zeolite you are using? Sodium zeolite is going to use for water softening method. This sodium zeolite having large number of microporous structure. porous structure. This sodium zeolite is simply written in the form Na2Z. Na2Z. Z is equals to remaining Na2O, Al2, O3, XSiO2, YH2O, etc. The sodium zeolite, whenever adding into the water, dissolving calcium and magnesium chlorides, bicarbonates, whatever it may be, combining with zeolite, and what more, the pure water is going to sending into the further process. Here small diagram I am drawing. Here the zeolite bed. Here hot water is coming to this tank. Here this tank contains what more, zeolite bed. Zeolite bed containing large number of microporous structure. Zeolite bed contains large number of microporous structure. Whenever hot water is coming to this tank, here this hot water containing many of calcium and magnesium dissolving salts. Here this is, whenever hot water is coming to here, this is what more, sodium zeolite, Na2Z. Here what happened, this Na2Z having large number of microporous structure. Whenever hot water is coming, dissolving calcium and magnesium salts, are stopping on the surface of zeolite bed. Here one minute, I am going to change small changes here.
Color sir, only color. White sir. Yes.
Here whenever hot water is coming to this inlet, this container contains what more, sodium zeolite. This sodium zeolite having large number of microporous structure. Due to presence of microporous structure, which is allowing only pure solvent, which means water molecules, all dissolving substances are stopping on the surface of this bed. The remaining pure water is going to pushing down. That water is pure and soft water. The remaining water is getting down, that is soft water. Soft water is collected here. Soft water is collecting from here. Okay. Here the remaining, here washings are coming. In the examination, what they are asking question, the exhausted surface bed is going to regenerated by using of what chemical? What chemical you are using? By exhausted zeolite bed is regenerated. Exactly what chemical is used? That question is many times given in the Ecet examination. Here exhausted zeolite bed is going to regenerated by the addition of brine solution. What is its chemical formula of brine solution? Sodium chloride. Whenever using, that sodium chloride is going to regenerate again fresh sodium zeolite by reacting with whatever the substance stopping on the surface of zeolite bed. That sodium chloride is helpful to remove exhausted bed is going to again regenerating as a fresh resin. Again this process is going to continue after regeneration of fresh zeolite resin bed. This is simplest and permutate or zeolite process. Here how the chemical reaction takes place also here I am showing. Whenever hot water is coming, which is going to react with the zeolite. For example, calcium chloride may be present in the water. That is going to react with what more? Sodium zeolite. They form what more? CaZ. Calcium zeolite they form, remaining 2 sodium chloride they form. Like this reaction takes place. This calcium zeolite or magnesium zeolite are stopping here in this area. This whenever continuously using this method, these resin beds are exhausted or blocked. Further filtration is not continuing whenever it is used for long time. That time what you are going to do for the regeneration of resin again means the regeneration of exhausted resin can be regenerated by the addition of brine solution. Addition of brine solution. How to regenerate also here I am showing regeneration. Regeneration can see CaZ is combined with what more? NaCl 2 moles. Here they form Na2Z. Again fresh zeolite is regenerated, remaining calcium chloride is formed. These washings these are removing from here. CaCl2, MgCl2 etc. removed from these washings. This is about permuted process. This is about permuted process. Similarly, I am going to explain about here ion exchange process. Ion exchange process. Here what is basic principle involved in this method? Long chain cross-linked organic polymers or resins are used which are containing functional groups. These functional groups can exchange polar functional group they contain. That polar functional groups can exchange the hardness causing cations and anion from the hard water. That is the basic principle involved in what ion exchange process. Ion exchange process. Here once again I am repeating, the long chain cross linked organic resins or polymers are used which are containing polar functional groups. These functional groups can exchange hardness causing cations and anion from the hard water. That is the basic principle involved in ion exchange process. Here cation exchange resin and anion exchange resin is going to use for the removing of cationic exchanging resin, and anionic exchanging resin are going to use for the removing of cation and anion from the dissolving hardness causing calcium and magnesium impurities. Here we have a simple diagram I am drawing. This is simple diagram which containing cation exchange resin in middle. This is what more cation exchange resin. Here hard water to come. This is what cation exchange resin. Here with the help of pump, this water is again sent into the one more tank. Again this tank containing what more anionic exchanging resin. Anion exchange resin. Anion exchange resin this. Anion exchange resin, that is what is formula R dash OH. This is cation exchange resin formula RCOOH. RCOOH. Whenever hot water is coming towards here, this cationic exchanging resin also having large number of microporous structure but allowing only what more pure solvent and anions etc. Cations are going to stop on the surface of this bed. Cations are going to stop on the surface of this bed. Cations are stopping here. Cations are stopping. Here I am showing what more with red. Here cations are stopping in that, remaining water is coming down. Remaining water is getting down. Remaining water is getting down, and that water is with the help of pump, this water is going to enter into the second tank. This second tank contains anionic exchanging resin. Anionic exchanging resin can exchange only anions. All cations are stopping here. The remaining water anions and H plus to coming here, that is going to enter into the second tank with the help of pump. Here all anions are going to stop. All anions are going to stop here. All anions are going to stop on the surface of this bed. Only the remaining H plus and OH minus is getting down. These two are combined to form pure water. That water is said to be what more demineralized or pure water. demineralized water. That water is said to be what more? Demineralized water. Very simple process. Hot water, whenever sending into the cationic exchange resin bed, cationic exchanging resin bed can exchange only cations. The remaining water getting down, that water is going to enter into the second tank. That second tank containing anionic exchanging resin can exchange only anions. The remaining water present in this H plus and OH minus, that is H plus and OH minus to combine to form pure water, that is said to be what more? Demineralized water or deionized water. Here this process also, how many days it is working? Whenever this process also used for long time, this method also, this microporous structure of anionic and cationic resins are also exhausted. This exhausted cationic exchanging resin can be regenerated by the addition of HCl. Exhausted resin beds are going to regenerated by using of what more? HCl, and exhausted anionic exchanging resin is going to resin by sodium hydroxide. This exhausted resin beds, how to regenerate, that is very important in the exam point of view. Here examination point of view, how the exhausted cationic bed is regenerated means hydrochloric acid is used to regenerate cationic exchanging resin. Here how the anionic exchange resin bed regenerated means sodium hydroxide is going to use it for the regeneration of anionic exchanging resin. Once again I am repeating, how the cationic exchange resin, exhausted cationic exchange resin, how to regenerate it means exhausted cationic exchange resin can be regenerated by the addition of hydrochloric acid, and next point here exhausted, here I am writing exhausted cation exchange resin can be regenerated by the addition of hydrochloric acid. That is very important for exam point of view. Again similar manner, exhausted anion exchange resin can be regenerated by the addition of sodium hydroxide. This is also very important. Exhausted cationic exchanging resin can be regenerated by the hydrochloric acid. Exhausted anionic exchanging resin can be regenerated by the sodium hydroxide. This is about ion exchange process, principle, work, construction and working, and what more, how this exhausted resins are regenerated also here discussed. Next I am going to explain next one, drinking water. What is meant by drinking water? Drinking water, which is also called as potable water. Drinking water, which is also called as potable water. Drinking water, municipal water, domestic water, etc. These many names are there. Here, what is drinking water? Listen, the water which is used for drinking purpose. The water which is completely free from dissolved contaminants, that water is said to be what more? Drinking water. The water which is safe for human being consumption is also called as drinking water. Here many definitions. The water which is used for drinking purpose is drinking water, or the water which is safe for human being consumption is called drinking water. The water which is completely free from dissolved contaminants is also called as what more? Drinking water. This drinking water have some specifications. The drinking water having some essential specification. Drinking water must be colorless, tasteless and odorless. What are the points? Just I am saying, the listen carefully. The drinking water should be colorless, tasteless and odorless. That is the first point. Next, second point, it should free from dissolved impurities like calcium and magnesium impurities. And next, third point, it should free from dissolved poisonous gases like carbon dioxide, sulfur dioxide, hydrogen sulfide, etc. Next, fourth point, it should free from dissolved poisonous metal like arsenic, stibine, mercury, etc. present in the water. That is also completely free. That is also one of the point. Here the water which is free from dissolved poisonous metal. That is one point. And also hardness should not exceed, hardness of water should not exceed 125 ppm. Here what is first point? Here first point is what more? Drinking water tasteless, colorless and odorless. It should be free from dissolved contaminants, free from dissolved impurities. It should free from dissolved poisonous gases like CO2, H2S, etc. Next, it should free from dissolved poisonous metals like lead, arsenic, mercury, etc. Okay. Here hardness of water should not exceed, hardness of water HW should not exceed 125 ppm. Total dissolved solids should not exceed 500 ppm parts per million, which means TDS should not exceed 500 ppm. All these essential qualities of drinking water. And also fluorides should not exceed 2 ppm only. pH of water in between 7.5 to 8.5. And also it should free from dissolved disease caused microorganisms. And also what more? It should free from disease caused microorganisms like bacteria, virus, fungi, etc. These are what more? Drinking water and essential qualities of drinking water. What are these essential qualities of drinking water? Before going to treat as potable water or drinking water, the water having all these qualities, then the water is suitable for drinking. is said to be drinking water or potable water. This is about drinking water. Next, municipal treatment of water for drinking purpose. Here, municipal treatment of water for drinking purpose. This, whatever the municipal water, they have different steps. What more? Sedimentation, coagulation, aeration, coagulation, etc. We have different points. Municipal treatment of water for drinking purpose, we have different steps. One is what more? Screening, sedimentation, coagulation, filtration, disinfection, etc. we have steps. Municipal treatment of water by drinking purpose means what are the steps? Here I am writing like flow chart. Here first what more? We are collecting water from source of water. Source of water you are taking. This water is going to passed screening process. After that what more? Aeration. It is going to treat on what more? Aeration. Then after coagulation. Just a minute. Before the coagulation we have what more? Sedimentation, sorry. Here after the aeration, sedimentation, next coagulation, these many steps involved. Filtration, disinfection. After disinfection to get what more? Potable water or drinking water. What are the steps involved in the treatment of potable water? Directly we are collecting the source of water, which may be groundwater or surface water. It can be treated on screening. What happens on screening? Screening is going to remove large floating impurities. Aeration process, what is going on? Just simply after the completion of screening, the water is going to enter into the aeration process in open vessel. It is directly interacting with the environment. It is going to increase the concentration of oxygen and removes dissolved manganese, heavy metal, causing hardness is going to remove, like manganese, nickel, copper, zinc, etc. hardness can be removed whenever aeration process. Why it is called aeration means whenever that water is open vessel they keep in the environment, oxygen concentration is going to increase on the water, then remove dissolved manganese, nickel, copper, zinc, etc. That is aeration process. Sedimentation process, whenever in sedimentation process dissolved suspended impurities are going to what must settle the bottom of the tank due to gravitational force. It cannot remove 100% of dissolved impurities, it can be removed by only 75% of dissolved impurities. Then after it is going to second step, it is coagulation. Whatever the impurities cannot be removed by sedimentation process, in this some external chemical is going to use and gets the precipitation takes place, that is called what more? Flow or precipitate, that is called what more? Coagulation. Mostly potash alum is going to use for the coagulation process. That whatever the precipitation occurs, that is going to filter. That filter contains coke layer, sand layer, gravel layer, corace layer, etc. Coke removes color and odor of the water, and remaining water is going to filter the water. After the filtration, the water is going to enter into the disinfection process. Disinfection method is going to remove whatever the bacteria present in the water or fungi, virus, etc. Disinfection means what? The process of removing disease caused microorganisms from water is called what more? Disinfection or sterilization. After sterilization process, that is going to what more? Treated as what more? Drinking water only. Here mostly disinfection purpose we are using what more? Chlorination. Chlorination is going to use for disinfection method, or bleaching powder is going to use for killing of dissolved bacteria in the water. This is about what more? Municipal treatment of water drinking purpose, municipal water drinking purpose. Here chlorination, here I am going to explain the chlorination. We have some what more? Chlorination, how to remove bacteria from the water. Here I am showing chlorination. The process of removing disease caused microorganism by the addition of bleaching powder or liquid chlorine is said to be what more? Chlorination. Here I am most efficient substance to kill the bacteria, and that is very cheapest method, that is by using of CaOCl2. What is this? Bleaching powder. Okay, whenever combined with water, bleaching powder whenever adding into the water, they form calcium hydroxide, 2 moles of water molecule, they produce what more? Chlorine gas, calcium hydroxide. And here not required 2 moles of what more? Water, only 1 mole is enough. Here only 1 mole of here only 1 mole required. Here only 1 mole of water, they produce what power? Bleaching powder is combined with water, they produce calcium hydroxide and chlorine. This chlorine again combined with water molecule, they produce HOCl, hypochlorous acid and hydrochloric acid. Name of this compound what more? Hypochlorous acid, which is highly unstable. Immediately this hypochlorous acid is going to convert into hydrochloric acid and liberation of nascent oxygen. Name of this what more? Nascent oxygen. This nascent oxygen having excellent characteristics, immediately it is going to combine with bacteria and they form kills bacteria. Here what happened? Bacteria combined with this nascent oxygen, they produce killed bacteria. This is generally involving whenever bleaching powder is added into the water or municipal treatment method. Why the people are going to kill dissolving presented bacteria in the water, whatever the bacteria present in the water, how the municipal people are going to remove dissolved bacteria means what more? By adding of bleaching powder only. Whenever adding bleaching powder, these many chemical reaction takes place finally to remove bacteria, or kill bacteria or destroying the bacteria by using of bleaching powder method. This is about municipal treatment of drinking water. Osmosis and reverse osmosis. What is osmosis and reverse osmosis? Osmosis. Here first of all I am going to discuss osmosis. The process of diffusion of solvent molecule from lower concentration to higher concentration through a semi-permeable membrane is called what? Osmosis. The process of diffusion of solvent molecule means water molecule from low concentration to high concentration through a semi-permeable membrane. Through a semi-permeable membrane is known as what more? Osmosis. Here which means what more? Here, 1 minute. Here, lower concentration to higher concentration. What more? Through what? Semi-permeable membrane. Through semi-permeable membrane. SPM means what more? Semi-permeable membrane. That is osmosis. What is reverse osmosis? Reverse osmosis. Here listen. The process of diffusion of solvent molecule from higher concentration to lower concentration. Higher concentration to lower concentration is known as what more? Reverse osmosis. The process of diffusion of solvent molecule from higher concentration to lower concentration through a semi-permeable membrane is known as what more? Reverse osmosis. When this process is goes to reverse direction, actually osmosis means which goes to lower to higher concentration, means the pressure required to stop the osmosis is called what more? Osmotic pressure. What is osmotic pressure? The pressure required to stop the osmosis is called osmotic pressure. Whenever applying osmotic pressure on the concentration side, the solvent is going to diffuse or moving towards what more? Higher concentration level to lower concentration level, that is what more? Reverse osmosis. Once again I am giving the statement of reverse osmosis. The process of diffusion of solvent molecule from higher concentration to lower concentration through a semi-permeable membrane is known as what more? Reverse osmosis. Here many times I use semi-permeable membrane. That is also I am giving to you information. Semi-permeable membrane means which allowing only water molecule, which means solvent molecules. Solvent molecules, a chemical substance which allowing only water molecule, that is said to be what more? Semi-permeable membrane. Semi-permeable membrane example: egg membrane, parchment paper, etc. Here a small diagram I am showing. Here this is the container which containing what more? Semi-permeable membrane here. Semi-permeable membrane here. Semi-permeable membrane which containing large number of microporous holes. Through this what more? Sea water I am taking. Sea water containing most of the salt. Most impure water, sea water, means highest concentration of salt. This highest concentration of salt water, whenever treating in the treatment of reverse osmosis process, here applying osmotic pressure. Here applying what more? Osmotic pressure. Osmotic pressure 15 to 40 kg centimeter square. Whenever applied, it goes to reverse direction, higher concentration to lower concentration, to come pure water. Pure water is collecting from this outlet. Okay, pure water is coming, and only here dissolving calcium and magnesium substances are going to stop here only. Dissolving calcium and magnesium substances are stopping on the surface of this bed only. Yeah, remaining water only pushing towards downwards through this semi-permeable membrane, that is pure water. That is pure water. Very simplest process. Whenever osmotic pressure applied, the higher concentrated salt water is going to pure lower concentration of water through a semi-permeable membrane. Semi-permeable membrane only allowing water molecules, not salt particles. Not salt particles. This is about reverse osmosis. Here sea water also purified what more in this method. Nowadays whatever the water purifiers using in home purpose, that is all working under the principle of reverse osmosis process only. Nowadays in the market available different kinds of brands. What are the brands available? Kent mineral water, Aquaguard, Aquafresh, etc. also under working the principle of reverse osmosis process. Reverse osmosis process. Next I am going to next topic, advantages of using reverse osmosis. Advantages of using reverse osmosis. Here this method is removes all impurities. Whenever this process, here what more, this method is going to remove all types of impurities. This method is removed all types of impurities like ionic, non-ionic, whatever the salts of or gases type, whatever the impurities can be removed. That is first point. The process, second one is the process and cheap and easily operating. This method is very cheapest method and very useful method. That is also one of the advantages. First one, this method can be removed all type of impurities. Second one, this method is cheap and most conveniently to use operating. And next third one, the semi-permeable membrane. Semi-permeable membrane is only allowing only water molecules, not salt particles. The semi-permeable membrane lifetime also nearly 2 years. Nearly 2 years. That is also one of the advantage. This technique is used in dialysis. And this technique is what me reverse osmosis method is going to use in dialysis also. These are the advantages of reverse osmosis. Reverse osmosis. Next, desalination by electrodialysis. Desalination by electrodialysis. Electrodialysis. Here what is meant by desalination? Desalination. Desalination means the process of removed common salt from water is known as what more? Desalination. What is desalination? Removal of common salt. Common salt means what more? Sodium chloride. The process of removal common salt from water is said to be what more? Desalination. Here desalination of electrodialysis. Here desalination of electrodialysis. Here whenever a compound is going to dissociate, they produce cation and anion, which means here removal of common salt in this method means what more, which is going to reduce by this process the salt concentration. Salt concentration is going to reduce by using of cation and anionic exchanging resins. Cation and anion exchange resins. Here same like electrodialysis. Here reversely, previous cation and exchanged by cation and anion can exchange by anions. Here electrodialysis, positive is going to attracted negative ions and negative is going to attracted by cations. That is said to what more? Electrodialysis. Electrodialysis whenever using and positive and negative electrodes, whenever dissolving calcium and magnesium impurities containing water enter into this. For example, and dissolving salts containing any salt, either including NaCl etc. also magnesium chloride. How to dissociate? Mg plus 2 plus 2Cl minus. 2Cl minus. Here electrodialysis means whenever the water is going to enter into like this, three compartments like here whenever hot water is going to enter, here for example negative, here may get what more? Positive electrode to present. Here what happen, whenever hot water is coming here that containing all these ions, here means magnesium 2 plus plus 2 is moving towards this and Cl minus is moving towards like this, and removes separating magnesium plus ions are removed from here and Cl minus ions are removed from here. Here pure water is going to collect from here. Pure water is going to collect. All dissolving positive and negative ions are going to removed by electrodialysis. Attracting of what more? Cation is going to attracted by negative electrode and anion is going to attracted by positive electrode. Simply different ions are going to removed by what more? Attracted by the oppositively electrodes and removed dissolving including common salt like hardness causing salts etc. is known as what more? Desalination by electrodialysis. Next here simple questions you can say Ecet examination, previous examination already given. Extra pure water can be obtained by using extra pure water is obtained by only dialysis process only. Here lime soda method not getting extra pure water and permitted process also is not getting extra pure water. Electrodialysis only 100% whatever the ions dissociated present in the water salt, that salt is going to dissociate into cation and anion. All cations and anions are going to moving towards respective electrodes and completely extra pure water to obtain, that is absolutely this is the option electrodialysis. Remaining options are wrong options. Next, sterilization of water can be done by using sterilization process means what more? Disinfectant. Here ozone also used for the purification of what more? Water as a removing of disease caused microorganism. Bleaching powder is used, chlorine used, ozone used, chloroamine used, different compounds. Here one of the compound is ozone is given, that is right option. Oxygen is not going to use, ozone is going to use. Caustic potash also not going to use, this is wrong option. And caustic potash also wrong option. And hydrogen peroxide also wrong option. Only right option is what more? Ozone is going to kill presented bacteria in the water. During reverse osmosis, what I say reverse osmosis? Here dissolved salts pushed out through semi-permeable membrane, not correct. Only dissolved ionic salts can be pushed out. Ionic, non-ionic also removed, not correct. Pure water is pushed out through semi-permeable membrane. What I said? Pure water, dissolving salts can be stopped on the semi-permeable membrane. Only solvent molecules are pushing throughout the semi-permeable membrane. That's why third option is going to what more? Right option. Third option is going to right option. Third option is right option. Third option is right option more. Third option is right option. Next, defluoridation. This we have last topic. Defluoridation means what? The process of removing common dissolving fluoride from water or minimize the dissolving fluorine from water is known as what? Defluoridation. The process of removing dissolving fluorine or maintains minimum level, which means below 2 ppm fluorine in water, is said to be what? Defluoridation. The process of removing dissolved fluorine from water is said to be what? Defluoridation. This defluoridation method is going to explain by Nalgonda technique. Here defluoridation means what? The process of removing dissolved fluorine from water is known as defluoridation. Or one more, the process of dissolving fluorine to maintain optimum level. To maintain optimum level is also called as what? Defluoridation. Here fluorine we can make fluorine to be present in the water to present as optimum level is called defluoridation, or to remove dissolved fluorine from water is also called as what more defluoridation. This defluoridation can be explained by Nalgonda technique. Nalgonda technique. Here Nalgonda technique was developed by NEERI. Here Nalgonda technique is going to developed by NEERI. National Environmental Engineering and Research Institute, Nagpur was developed this Nalgonda technique. What is the main aim of this Nalgonda technique? To remove of fluorine from water. To remove of fluorine from water. Here Nalgonda technique is going to explain to removal of fluorine from water. Here by rapid mixing of, here what are the chemicals they are using? Rapid mixing of aluminium sulfate, rapid mixing of aluminum sulfate, comma, bleaching powder, alum, comma, lime. This is not required. Bleaching powder is going to kill what more? Only this is the rapid mixing takes place. Here what are going to mix? Aluminum sulfate, alum and lime can be used. What is the alum chemical formula? Here I am going to give alum chemical formula one by one. Here what is alum chemical formula? Here only I am writing in bracket, check it. Here aluminum sulfate Al2SO4 taken thrice, that is alum, lime calcium hydroxide, and alum, for example potash alum K2SO4, Al2SO4 taken thrice, Al2SO4 taken thrice, and 24H2O is said to be what more? Potash alum. By rapid mixing of all these three chemicals and dissolving fluorine is going to minimize whenever reacting with fluorine all these chemical compound. Finally to going to add bleaching powder, finally we add CaOCl2 for killing any type of bacteria, any type of disease cause microorganisms. Okay, this is very simplest method. Nalgonda technique is going to develop NEERI, National Environmental Engineering and Research Institute was Nagpur. The rapid mixing of these three chemicals are going to minimize the fluorine from water or maintaining optimum levels by reacting with this aluminum sulfate, calcium hydroxide and potash alum, etc. For removing of after that fluorine, finally we are going to add bleaching powder, and also what are the disease caused microorganism also to be present, that is also is going to kill. This is about Nalgonda technique. Here few questions I am going to discuss with you. TS Ecet examination. Here which of the following statement is true about smog? Smoke is derived from the fog, it is not correct. Smoke is derived from the smoke is not correct. Smoke is derived from the water vapor, not correct. Here what is the right option? Smoke is derived from both the fog and smog, that is the right option one. This is the right option. Smoke is right option. Next question, exhausted permutate regenerated by using, already this question already explained in theory. Exhausted permutate is regenerated by the using of dash. What I given, brine solution I given. The given chemicals, what is brine solution? Calcium chloride is not called as brine solution, and HCl is not called brine solution. Sodium chloride is called what more? Brine solution. This is the right option. This is called brine solution. This solution is going to use for the regeneration of this. These three are wrong option. This is only right option. Exhausted, permitted, regenerated by using of what more? Sodium chloride. This is a small problem. Temporary hardness of water containing 16.2 milligrams of calcium bicarbonate and 7.3 milligrams of magnesium bicarbonate per liter. Here temporary hardness of water, how to calculate? I already used one formula. Hardness of water in terms of CaCO3 equivalents is equals to what I give formula? Weight of hardness causing salt divided by GMW of hardness causing salt into 100. This formula you can use and calculate. For example, first one, what is given salt for calcium bicarbonate? Calcium bicarbonate hardness how much? They are given 16.2 here. For this 16.2 and calcium bicarbonate gram molecular weight 162 into 100 to get here what more? Total 10 milligram per liter to come. 10 milligram per liter for come calcium bicarbonate. Magnesium bicarbonate is equals to same formula. They are given what more? 7.3 is given weight. 7.3 divided by 146 into 100. What is to come here? This one I am writing like this: 73 divided by 146 into 100 by 10. Here 10 cancel, and 73 1 ja 73 2 ja 2 1 ja 2 5 ja. Total to come here 5 milligram per liter. Here total how much to come? 10 plus 2. 10 plus here what is coming? 5 to come. What is coming answer? 10 plus 5 to come. Here after the cancellation 73 1 ja 73 2 2 ja 2 5 ja. Here to come what is the answer? 5 to come. Here total what is hardness? Calcium bicarbonate 10 milligram per liter, magnesium bicarbonate 5. These two sum. What is hardness? Total temporary hardness of water is equals to calcium bicarbonate plus magnesium bicarbonate. 10 plus 5, 15 milligram per liter. Where is answer? You can check it. 15 milligram per liter answer is here. Third option, this is the right option. Remaining options is wrong options. We need to solve given question by using of this formula. By using of this formula you can calculate this hardness. This is one question. When the hard water is boiled, the precipitate formed is, when the hard water is boiled, what is precipitation formed? Whenever magnesium sulfate not precipitated, this is wrong option. Magnesium chloride also not precipitated, calcium carbonate also not precipitated. Only bicarbonates, whenever heating, precipitation to occur, this is belongs to temporary hardness of water. Next, chemical formula of zeolite. What is chemical formula of zeolite? Na2O, Al2O3, XSiO2, XH2O. This is the chemical formula of what more? Zeolite. The remaining all what more? Not chemical formula of zeolite. What is chemical formula of zeolite? Na2, Al2, SiO2, XSiO2, YH2O. This is the chemical formula. What is chemical formula of sodium zeolite? Na2O, Al2O3 dot X SiO2 YH2O. This is the chemical formula of zeolite. Exactly this chemical formula is suitable for this second option. Next, choose the incorrect statement from the following options. Here the question is given, carefully you can observe. Incorrect option. incorrect statement, we can find given 4 options. In hot water, the detergent values of soap are decreased. In the presence of dissolved hardness producing salts, the boiling point of water is decreased. That is, what more? In the presence of dissolved hardness producing salts, the boiling point of water is decreased. Boiling point of water is decreased. It is wrong option. Whenever dissolving salts, dissolving hardness present in the water, boiling point is going to increase. It takes extra time to boil. That is the right option. And third also you can say incorrect statement is only second. The water which does not form lather with soap is called hard water only. Correct statement only. The hard water consists of calcium and magnesium salts in dissolved state only present in hard water. All right options only. Second option is going to what more? Incorrect statement. They are asking incorrect statement. In high pressure boilers, scale formation can be avoided by adding. In high pressure boilers, scale formation can be avoided by adding of what more? Sodium phosphate. What is here? Sodium carbonate is not, sodium hydroxide is not, sodium meta-aluminate is not, sodium phosphate is going to used for avoiding of scale formation in what more? High pressure boilers. High pressure boilers. Sodium carbonate is not going to use, sodium hydroxide also not going to use, sodium meta-aluminate also is not going to use. Sodium phosphate Na3PO4 is going to use for removing of what more? Scale formation in high pressure boilers. The basis of reverse osmosis is, what I say reverse osmosis, diffusion of solvent from higher concentration to lower concentration. You can read these statements, whatever given 4 options. Osmotic pressure is greater than the hydrostatic pressure. Osmotic pressure is equal to the hydrostatic pressure. Hydrostatic pressure is greater than the osmotic pressure, and osmotic pressure does not exist. Out of these 4 statements, according to reverse osmosis, what is correct? Hydrostatic pressure is greater than the what more? Osmotic pressure, also not correct. Osmotic pressure is equal to the hydrostatic pressure, also not correct. Osmotic pressure is greater than the hydrostatic pressure is the correct option. Means whenever applying osmotic pressure, then only that goes to reverse direction. Actual osmosis means lower to higher concentration. Whenever applying osmotic pressure, it goes to reverse direction, higher concentration to lower concentration. Based on that, first statement is going to right option for the given question. Next, hot water can block radiators due to the formation of. Here hot water can block radiators due to the formation of what more? Insoluble calcium and magnesium salts, insoluble sodium salts, insoluble phosphate salts, insoluble potassium salts. I said hardness is.
Yeah, hi. Hello students.
Hello student, just a minute.
Just a minute, a small announcement to all the students. So who are now is working on it. Right. So students, ఎవరైతే ఈ ఆన్లైన్లో వీడియోస్ చూస్తున్నారో ఈ లైవ్ క్లాసెస్ ప్రస్తుతానికి, సో యాజ్ పర్ ది ఇన్స్టిట్యూషన్స్ నామ్స్ ప్రకారం ఏంటంటే ఈ లైవ్ క్లాసెస్ కండక్ట్ చేసినప్పుడు చూస్తున్న పిల్లలకు ఇంకొక చిన్న అనౌన్స్మెంట్ ఏంటంటే ఈ టోటల్ లైవ్ క్లాస్ అనేది ఒక దగ్గర ఒక అప్లికేషన్లో పెట్టడం జరిగింది బేట. సో మీరు ఆస్క్ ఇంజనీరింగ్ అకాడమీ అనేది మీ యొక్క ప్లే స్టోర్లో మీరు డౌన్లోడ్ చేసుకొని లాగిన్ కండి. లాగిన్ అయిన తర్వాత మీకు ఈ కోర్సెస్ని బై చేసుకోవాలనుకుంటే దాంట్లో ప్రీ రికార్డెడ్ కోర్సెస్ అన్నీ ఉంటాయి. సో ఇవన్నీ ఫ్రెష్గా చేసిన కోర్సెస్, ఎప్పుడో ఒక 2 సంవత్సరాలు 3 సంవత్సరాల కింద చేసిన కోర్సెస్ కావు. చాలామంది స్టూడెంట్స్ నన్ను అడుగుతుంది ఏంటంటే ప్రస్తుతానికి ఫ్రెష్గా చేసిన కోర్సెస్ లేవు ఎక్కడైనా, సో పాత ఎప్పుడో చేసిన కోర్సెస్ ఉన్నాయో వాళ్ళు చాలా ప్రిపరేషన్కి ఇబ్బంది అవుతుందని చెప్పారు. సో దానికోసమే నేను ఫ్రెష్గా కోర్సెస్ చేసి ఈ ఇయర్ అంటే ఈ 2025కి సంబంధించి ఇందులో ట్రై చేయడం జరుగుతుంది. గత 3-4 ఇయర్స్ బ్యాక్ నేను చేసిన ఆ వీడియోస్ మళ్ళీ తిప్పి వేయకుండా అండ్ ఓవర్ కంటెంట్ మీకు లోడ్ కాకుండా ఉండడానికి, సో వెరీ షార్ట్ అండ్ స్వీట్గా మీ ప్రిపరేషన్ కంటిన్యూ కావడానికి. సో ఇక్కడ ప్రీవియస్ క్వశ్చన్స్ అంటే ప్రీవియస్ కాన్సెప్ట్స్ అని ఎక్స్ప్లెయిన్ చేసిన తర్వాత మళ్ళీ ఈ పర్టికులర్ ప్రాబ్లమ్స్ ఏవైతే ఉన్నాయో అంటే ప్రీవియస్ క్వశ్చన్స్ ఎలాంటివి అడిగారో వాటిని మనం డిస్కస్ చేయడం జరుగుతుంది. చాలామంది స్టూడెంట్స్ ఏంటంటే ఏదో అంత లైక్ ఎక్కువ డేటా మీరు చెత్తంతా ప్రిపేర్ కావడం వల్ల మీకు టైం అనేది లాస్ అవుతుంది అండ్ ప్రిపరేషన్ మాడ్యూల్ అనేది కరెక్ట్గా వెళ్ళారు కాబట్టి సో ఒక పర్టికులర్ చాప్టర్కి 2 hours మనం పెడుతున్నాము. 2 hours పెట్టిన తర్వాత అది దాంట్లో ప్రీవియస్ క్వశ్చన్స్ కాన్సెప్ట్స్ అన్నీ కవర్ అవుతుంది. సో అందుకోసం మీకు ఎవరైనా ఇంట్రెస్ట్ ఉంటే ఈ పర్టికులర్ వీడియోస్ అన్నిటినేమో ఆన్లైన్ మన యొక్క ఛానల్ ద్వారా మీ అందరికీ అవైలబుల్ ఉండేట్టు ఒక అప్లికేషన్ తీసుకురావడం జరిగింది. మన యొక్క మొబైల్ అప్లికేషన్. ఈ మొబైల్ అప్లికేషన్ మీరు డౌన్లోడ్ చేసుకొని ముందుకు అంటే దాంట్లో ఉన్న అన్ని వీడియోస్ మీరు చెక్ చేసుకోవచ్చు. అన్ని క్లాసెస్ ఈ విధంగానే టీఎస్ ఈసెట్ ఏదైతే మనకు అనౌన్స్ చేసిన సిలబస్ ఉందో అదే సిలబస్ అదే మీకు ఉంటాయి. మీకు ఇంట్రెస్ట్ ఉంటే మీరు